Let's move on to a few more of these related rate problems. And for my next example, I have a conical tank with a radius of 3 meters and a height of 4 meters. And the tank is being filled with water at a rate of 18 pi meters cubed per minute. And I want to find out how fast is the water level rising when the water is 2 meters deep. All right, so there's quite a bit of information here, so let's try our best to break this down slowly. I have a radius of 3. All right, so on my diagram here, that represents this blue line, so the radius is going to be 3. And then I also have a height of 4, so the tank has a height of 4, so that's going to be represented by this red line. And this tank is being filled with water at a rate of 18 pi cubic meters per minute. So if I have 18 pi cubic meters per minute, then what that really tells us is that since I have cubic meters, that's going to be dV. That's my volume, dV. And since my denominator is in minutes, that's going to be dV divided by dt. All right, so my volume is changing at a rate of 18 pi cubic meters per minute. After that, I need to find out how fast is the water level rising, right? So water level is represented by height, so that's going to be dH over dt. I want to figure out what that is, and I want to find out exactly how fast that height is increasing when the water is 2 meters deep. So the height here is going to be 2 meters, and I want to find out what dH over dt is when the height is 2 meters. All right, so in order to kind of like move on with this problem here, I need to find a formula that connects the volume of this conical tank with the height and the radius and all that. So the formula that best works is the volume of a cone. So that's going to be volume equals to 1/3 pi r squared times the height. Okay, so since the conical tank has the shape of a cone, we will use the volume of the cone. All right, so when you take the derivative of volume, you're going to get dV by dt. If you take the derivative of h, you get dH over dt. If I take the derivative of r, I get dr over dt. But the problem is I'm not given dr by dt in this problem. So therefore, I need to get rid of my r variable. And once again, the reason why I have to eliminate the radius is because if I did take the derivative, I would get dr over dt, and there is no dr by dt value in this problem. All right, so that's step number 1. We have to get rid of the radius because if I take the derivative, I just wouldn't be able to move forward with the problem. So this is how you get rid of the radius for one of these conical tank problems. You want to go back to the original diagram of your cone here, and you want to write the radius and the height as a ratio and use the concept of similar triangles. Well, how do you write this as a ratio? Well, the height is 4, right? So it's going to be 4 divided by 3. So the ratio of the height to the radius is 4 divided by 3, and then you just make that equal to this radius here and this height. So the r and that h, the small r and the small h represent any radius and any height. So this will be h, remember height with height, divided by r, so radius with radius. So we're writing the ratio of the height to the radius because this is a similar triangle because we have a smaller triangle within the bigger triangle. Okay, so what I mean by that is if you take a look at this this orange triangle here, I'm not sure if this is coming out here, this orange triangle, that orange triangle is a smaller triangle within this bigger green triangle, so you can always set up the ratios as a similar triangle. Once we do that, let's go ahead and try to solve for r here. So let's do a crisscross. So that's going to be 4r equals to 3h, and then we divide both sides by 4, and my radius is going to be 3 over 4 times h. So we're going to use this radius. The radius is equal to 3/4 of the height, and we're going to replace this radius with the radius in our volume equation. Okay, so let's do that. So now my volume is now equal to 1/3 pi, and then this would be 3 over 4 h, all to the power of 2 times another h. All right, so let's go ahead and simplify this. This would be 1/3 pi. And if I square this, then 3 to the power 2 is going to be 9. So it's going to be 9 divided by 4 to the power 2 is going to be 16. And then this will be h squared times h. And h squared times the h here, that will be h to the power of 3. So I'm going to erase all that and just write h to the power of 3. And hopefully that's okay, because all I'm really doing is I'm taking this h squared and I'm multiplying with that h, which gives me h to the power 3. And now this is going to equal to my volume. All right, after that, let's go ahead and take the derivative now. So this will be dv divided by dt. This part right here, that's all a constant, so we can just leave that alone. So that's 1/3 pi times 9 over 16. So the constant remains the same. What we need to worry about is this derivative right here. The derivative of that is going to be 3. Sorry, that 3 didn't come out correctly there. So that's going to be 3 h to the power 2 times dh by dt. And after that, we go back to the information that's provided to us, and we fill in the numbers for dv by dt and the h. And if I go back, those numbers are 18 pi for the volume, and the height will be 2. So these are the numbers that we need plugged back into our formula. So this dv by dt was 18 pi equals to 1/3 pi times 9 over 16 times 3, and my height is was 2, so 2 to the power of 2, and then finally I just solve for this dh by dt. So our end goal is to solve for dh over dt, and if you want to use a calculator to figure this out, you definitely can. What I see here is the pi's can cancel off. I see that the 3's can cancel off. This expression right here is 4. 2 to the power 2 is 4. And 4 divided by 16, that's going to be a 4 on the bottom. So that's 9 over 4. And then I have the 18 on the left-hand side. And I have the dh over dt on the right-hand side. If I go ahead and move the 9 down, 18 divided by 9 is going to be 2. And if I multiply the 4 by the 2, I get 8. So my final answer is 8 meters per second equals to dh over dt. And just to kind of finish off here, we just checked that our units line up. So the denominator is in time and the height is measured in meters. So the final answer is 8 meters per second.